Welcome back to Cosine Law Part 2. So in this one, we're going to have a look at triple S, or side, 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 which is about finding missing angles using the cosine law. So our task is to find angle X. So we're missing a few labels. So let's give this thing a name. I guess the convention would be to call it ABC. Okay. And recall that in terms of the cosine law, across from angle A, we have side A. So the expression would be A squared equals B squared plus C squared minus 2BC multiplied by the cosine of A. Okay. Now the only issue with that, it's great for finding sides, but it's not all that helpful or convenient when it comes to finding angles. So my suggestion to you guys would be, could we solve for this? Could we rearrange the formula in such a way that everything is isolated to one side? I think that would be a whole lot easier. So let's start by balancing this thing out. Okay, so recall that because there's a multiplication here, okay, that this term here, there's not a whole lot that we can do with 2bc cos A. But what we can do is we can create some zeros. So what I mean by that is we could zero out b squared. And we could definitely...
Attention, high school students interested in attending the dance tonight, please come to the main
Just an
office.
announcement online here.
Ticket for tonight. After this, the price will increase tonight. You can for this ticket.
Everybody getting that? The price will increase tonight.
So, 5 minutes, they will be for sale in the office. Secondary dance tonight.
That's right. Thursday night glow dances tonight. Okay, so back to it. So what you do to one side, let's keep the equation balanced. So we will subtract b squared and c squared from the left-hand side too. So according to the color I have here, I'm just going to write it minus b squared minus c squared plus the a squared that was already there is going to be equal to what we have left here, okay, which is minus 2bc cos A. All right, so I'm just going to reorganize this a little bit. So what we have now is we have a squared minus b squared minus c squared equals minus 2bc cos A. Now that this term is entirely on its own, we can focus on... Lots of announcements during this screencast. What we can do is we can now reverse the multiplication here and solve for cos A. Let's divide out by minus 2bc, and we'll do that to both sides. So minus 2bc. So that's going to create, this is going to cancel 2bc over 2bc. So we end up with 1 over 1 in lowest terms. And then I'm going to write down a couple more steps, but as an intermediate, let's tidy this up. So we're all looking at the same thing, and that equals cosine of A. So a couple more things. One thing that we can do is that the negative that we have here, okay, it would be kind of nice if that were positive. So here's a suggestion. Why don't we take every term in the numerator, okay, the whole numerator. So let's take a squared, let's take negative b squared, and negative c squared, and let's divide those by by a negative, okay? So what's going to happen there, as you can imagine, is that in the denominator we'll have a positive 2bc, okay? And then in the numerator we're going to end up with a positive b squared, positive c squared, and then we'll flip the sign on the a squared. It's going to become minus a squared, and that's equal to the cosine of A. Okay. So you can start to see and maybe appreciate that these formulas for solving the angles that we can pattern again, right? Add two squares, subtract the square of the side for the angle that you're looking for, and divide by 2bc. So let's finish this off. Okay, last but not least, let's grab a different color from up here. Let's go with purple for a change. So we want to solve for A. So remember that to return the angle from its cosine, we're going to need to take the inverse of that. So let's take the inverse of this expression, b squared plus c squared minus a squared, all over 2bc. That gives us angle A. Okay, so anytime that you're applying, you're thinking to SSS, this particular formula down here, this is exactly the style, exactly what you need to be using to save yourself a lot of precious time in terms of rearranging the formula. So for instance, let's go ahead and try that out. Let's substitute into this. So cosine, or the inverse cosine of, let's grab some side lengths. So b squared, 35 squared, c squared, that's given as 32 squared, minus a squared, which is 22 squared, all over 2bc. So 2 multiplied by 35 multiplied by 32. And that's going to be equal to the value of angle A. So let's see, I know the bell just rang. We're going to get a rush of people coming in very soon. So let's see if we can't finish this off in our cast. I would always encourage you guys to try out the calculations as well, just to see if your calculator is doing things accordingly. So I'm going to equals right now. There's my numerator. And let's divide by everything on the bottom. So let's divide by, I can open up some brackets. So 2 multiplied by 35 multiplied by 32, close bracket, that equals, and that's going to give me the quotient, which is the answer to a division problem. And with that, take our inverse, get our cosine, which is about 38 degrees. So A is approximately 38 degrees. And there you have it, the application of the cosine law to a side example. And let's continue this tomorrow in class. So as far as solving the triangle, go back and maybe not for both, but try one of the other angles. Bring that work back into class tomorrow so we can have a look at it.